Okay, so welcome to part two. We're going to just lead off with it wants us to use calculus to determine the following for the function f of x equals x e to the x squared. We need to first find all our critical points for f. Work must be shown to receive credit. Well, our critical points are whenever f prime of x equals 0. So we're going to have to take a derivative. And so looking at this function, I see that we have this x e to the x thing, and we also have this to the power of 2. And so I almost think about this like an inside and an outside thing. So we're going to have a chain rule. But also, whenever you take a derivative of two things with x's that are multiplied, we're going to have a product rule. So there's just a couple things to note. So I'm going to say my outside thing, I'll call f. And don't confuse this with this f. This is going to be a different one, just to help me do the thing. And it's something squared. And that my g is the inside thing, which is x e to the x. And when we have a chain rule, the chain rule says that if you have f of g of x, we're taking the derivative of that. We're going to get f prime g of x times g prime of x. So our f prime will be 2x. And our g prime, well, now this is our product rule. So it's going to be derivative of the first one. Derivative of an x is just 1. Times what we have times the other thing. So 1 times e to the x, just e to the x. Plus the first one, we're just going to keep that the same, times the derivative of the second. So we do derivative of the first, keep the second, and then we do keep the first, derivative of the second. Now, what our chain rule says is f prime of g of x. So I have my f prime is 2x. Instead of this x, I'm going to plug in my g. So 2x e to the x times g prime of x, which is going to be e to the x plus x e to the x. And so I found my derivative. This is f prime of x. This is the original. This is that f prime, not this one. This was just a filler step. And I need to set that equal to 0. So it's the times. 0 is going to be 2x e to the x times e to the x plus x e to the x. I'm going to go ahead and I'll distribute that. So I have 0 is 2x e to the x times e to the x. It's going to be e to the x squared, or e to the 2x, plus 2x squared e to the 2x. Well, I can go ahead and I can factor out my e to the 2x. And I'll factor a 2 out with it as well. So I'm left with x plus x squared. And e to the x, one of the things that's really nice about it is that if we were to try to graph it, it looks like this. And notably, it never reaches 0. So I have something times e to the x, and I'm told it's 0. I can ignore this part, because that can never equal 0. So in other words, I can divide by it and solve for that. In which case, I can factor out an x. So I got that it's when x equals 0 or x equals -1. And I could get rid of my e to the x because it can't equal 0, so I can divide both sides by it. So my critical points are x equals 0 and x equals -1. So now we determine the absolute maximum and minimum of f of x in the interval -2 to 1/2. Well, whenever we do that, what we're going to do is we're going to check our critical points and we're going to check our endpoints. And we're going to see what the values are at each of those. So the first one, our spots we're going to check are -2, -1, 0, and 1/2. So we're going to go and plug each of those into our original function, and we can use that, and we can determine, like, based on the values, we can say the biggest ones will be our absolute maximum, our smallest ones will be our absolute minimum. So I'll try -2 first. I'll go ahead and write out what my f of x was, actually. X e to the x squared. So f of -2 is going to be -2 e to the -2 squared, which is going to be, plugging that in my calculator, I'll get about 0.073. I'll try f of -1 next. We get -1 times e to the -1 squared, which will get us about 0.135. I'll try f of 0, which is going to be 0 times e to the 0 squared. Well, 0 times anything is 0, so that's going to be 0. I don't have this estimate because I know that's an exact value. Then we do f of 1/2. We have 1/2 e to the 1/2 squared. And again, plugging all this into my calculator, what you should get is 0.68. So our largest one happened at 1/2, so I'll say like f of 1/2 being 1/2 e to the 1/2 squared, which is approximately 0.68, is the absolute max on our interval, because maybe somewhere outside of our interval it can reach something greater. So we want to specify. And our lowest value, well, that was going to be the 0, 1. So f of 0 equaling 0 was the absolute minimum on -2 to 1/2. So now for number 3, for 4 points each, evaluate the limits, say if or state that they do not exist, which we will use D and E to notate that. Use infinity or negative infinity if that is like when it says appropriate. So those are options. And then numbers alone without justification will receive no credit. Sorry about that. If you use L'Hopital's rule, clearly indicate when we do so. Okay, so let's look at this first one. Limit as x approaches 5. Well, on top, that's going to get close to 5 squared minus 25. And I'm only checking this just to make sure, like, if this is like a normal thing that we can just evaluate, then that'll be fine. So we bring it 0 over 5 minus 20 minus 25. And 5 minus 20 minus 25, that's going to be what, negative 40? So 0 over minus 40, that's just going to go to 0. Because we're not getting like any kind of like undefined thing or asymptote on the bottom as we approach 0. As we approach x equals 5, then that's fine. So the top's going to approach, this is going to approach 0. This is going to approach minus 40. So 0 over minus 40 is going to be 0. Okay. For this one, limit as x approaches 0, well, this thing's going to approach 0. And tangent of x as you approach 0, you can try and put that on your calculator, you should get out 0. So we have 0 over 0. What do we do? Well, that's when we say we use L'Hopital's. Got to make sure we specify that. So we're taking the derivative of the top, derivative of 3x to the third, it's going to be 9x squared. The derivative of the bottom, which is derivative of tangent, that's going to be secant squared. That should be on the last page of your exam usually. So we have over secant squared of x. and we check our limit again. Well, before I do that, I'm going to first think about this for a second. Secant is the same thing as 1 over cosine. So that means that 1 over secant is just cosine, aka I can turn this into the limit as x goes to 0 of 9x squared times the cosine of x squared. Well, this goes to 0. This goes to 1. 0 times 1 is 0. So this whole limit is going to go to 0 as well. Okay? So now this wants us to compute the following derivatives. I'll switch color because it's a different problem. And do not simplify. So this is more so just checking in to see if you know a couple of your rules. So whenever we do this one, we have something on top, something on bottom. This is going to be some form of quotient rule, which is that if you have f over g, it's going to be f prime g minus g prime f over g squared. And there might be some other stuff, like an e to the sine, that might involve a chain rule. So what I'm going to do is I'm going to label with my f. It's my g. This is, f is different than f theta, so my f is e to the sine theta. G is just theta. So f prime, well, that's going to be a chain rule. So derivative of e to the something is just itself, but because of chain rule, we got to multiply that times the derivative of the inside. Derivative of sine is cosine. So derivative of the outside is just e. We're going to keep the inside the same. Then times derivative of the inside, which is cosine. G prime, well, in this case, theta is a variable we care about, so it's just going to be 1. If you have just a variable and you're taking that derivative, you just get 1. So when we put this together, we'll have f prime, so e to the sine of theta, cosine of theta, times g, so times another theta, minus g prime, which is just 1, times e to the sine of theta over g squared, which is theta squared. And that's it for that one. Okay, so for this one, it wants us to find the second derivative, which they say d squared y dx squared of y with respect to x. So we're taking a derivative, we're going to take it again. So our function is y equals 2 to the x squared. And looking at this, I can kind of think of this. First off, this seems like a lot, but I'm going to say that there's an outside thing, which is 2 to the power of something, and an inside. So for my when I have an outside and inside, I think chain rule. So that's saying that if I'm doing the f of g of x, the derivative of that is f prime g of x times g prime of x. So my outside thing will be 2 to the x. My inside thing is x squared. I'm kind of like just been brushing on that. To check, you should say, if I replace my x in my f function with my g function, do I get back to what I originally had? So if this x became an x squared, yes, I would be back to what I originally had. So f prime, well, when you have a derivative of any b to the x, it's natural log of b, where b is like a number. It's like your base, times b to the x again. So this is going to be just natural log of 2 times 2 to the x. And g prime, it's just going to be 2x. So f prime, so I'll say dy dx, our derivative, it's going to be our f prime of g of x, so it's going to be f prime. But where I have that x, I'll put my g of x back in, times g prime of x, which is going to be times 2x. And I'm going to go now over this one more time, just to group. I'll just move the 2 out front just to group all the non-x stuff together. So that's my first derivative, but now I need to find my second derivative. So I'll take a derivative of this. Oh, that was not supposed to be a natural log of x. That's supposed to be a natural log of 2. That's my bad. Sorry if that was confusing. Almost did that again. Okay. Well, one thing that's going to be really helpful is if you have a number just in front, and that's just some ugly number. And we take a derivative involving that, that number is just going to stay in front. And so I have two x things, I'll have a product rule. So d squared by dx squared. So product rule says we're going to take a derivative of the first one, and I'll just group this whole thing as the first one. And we keep the second one the same. So first derivative of the first one. Well, the constant will always just hang out. And derivative of 2 to the x squared, well, that's just what we did. Derivative of 2 to the x squared, that was our first question. And that's just going to be 2 natural log of 2 times 2 to the x squared times x. And then keep the second one, so just times x, plus, just keep all the first thing the same. A derivative of just an x is 1, so times 1. And that is our second derivative. And since we don't have to simplify, so we can just leave it like that. Going back, that was our derivative for that one. And that's it. We're done with that.